Concealed carry. First words on the recording. Oh my gosh.
I think people know now just to
That was the upgraded music. The original music for the 200 class was this. But I figure Rickrolled was better. All right, so here's our cave.dat, right? This is what it looks like. So you're supposed to write a parser for this guy, correct? And did we already start the parser, or did I just put it in driver? Yeah, I just put it in driver. So we create our file input stream to wherever that dat file was. Right now I'm reading it in and just printing out, well, I'm reading it in, concatenating everything onto this string called JSON and printing out the JSON, and that's the output. So what you were to do for your homework is to parse through this, not actually build rooms and caves, but parse through it and show that you have the steps, the pieces to build rooms and caves, correct? An accurate statement? I didn't actually ask you to build the rooms and caves, or did I? Okay. Okay, so we need to create our parser. So we're going to create a new class called CaveSon parser. CaveSon. Get it? You people are no fun.
not when you make jokes like that.
CaveSon parser is kind of funny, isn't it?
You said better.
Well, obviously. But it's still kind of funny. So we're going to write our constructor for this. Public CaveSon parser. This guy will take a string, JSON as a parameter. And just for right now, we'll create a private string JSON. And we'll set this dot JSON equal to whatever was passed in. All right, and I'll just quickly make a display method. System.out.println this dot JSON. Okay, so that's what our CaveSon parser will do right now. See, it's already rolling off the tongue. CaveSon parser. This is gold, people. So I'll go back to driver. At the very end here, I'll go ahead and create an instance of CaveSon parser, then we'll upgrade it. So we'll pass it the JSON, then we'll say csp.display, and we print out the JSON. Now, what we probably want to do is we probably want to take all this crap that we have in here, and we probably want to actually put this inside the constructor of CaveSon parser, so we don't have driver all gucked up with all this other stuff. Okay, so I'm going to take all this code here. Actually, I'm going to take most of that code here. Cut it out of there. Go into CaveSon parser. And instead of this guy taking in JSON, it's going to take in the path to the file. We'll start JSON off at the empty string. Paste all this other code in here. I'm going to steal this line from my path. And we'll pass that guy path. And we're going to concatenate onto this dot JSON. Okay, Now this guy has a possible file not found exception, so what we'll do is we'll put all of this inside of a try catch and do nothing with it for right now. Alright, so we're going to try to create our file input stream given whatever path we sent this guy. Then we'll create our scanner, and we'll concatenate everything onto our field called JSON, and then we can then call our display method, which knows how to print out JSON. So now when we create a caveson parser, we'll pass it our complete path to our file, and then tell it to display itself. All right, so we've encapsulated that data. We've encapsulated the ability to read from that file inside of our caveson parser. Caveson parser. Caveson parser is a completely different thing. All right, makes sense? So that's the start of it. So at this point, we haven't done anything more than we did in class last time, except for the fact that we've encapsulated it inside of an object. Now we need to actually parse it. So this guy currently looks like this. Now we know that a cave is initially one room. And a room is a treasure and zero, let's just say 0 or more rooms. It's 0, 1, or 2 rooms. But for right now, we'll say 0 or more. I think that'll make more sense for our code here. Okay, so we're going to start off. We're going to have a private function here. We'll decide how we're going to do it here in a second. So we're going to say private void process cave. We'll do that first. And the job of this guy is to get the initial room from the cave, right? So all a cave is a room. So again, our code currently looks like this. So we need to peel off this, and we need to get to this initial room. Okay? That is our value of room, is it not? So we're going to go ahead and we're going to grab the initial value for room. So we want to get all of this information here. That's the contents of our room. So this guy is the JSON or caveson representation of a room. Okay? So we're going to get our initial room. So how do I peel off everything up to that point? What do you think? How'd you go about doing this? How many of you got this to work? 4.5, 5, 4, 3.5. 4.5, 5. I'm just assuming Batman cheated. Or is it bare hands?
Right.
It's bare hands. I prefer bare hands. All right, so what I'm going to do here is I'm first, and actually I'm going to do that up here. After I get my JSON string, I'm going to say this dot JSON dot trim. That'll give me the trimmed version of JSON. So I'm going to set this.json equal to this.json.trim. What that does is it removes all white space from the beginning and the end. Huh?
How do you do that? It already has the formatting in it.
Well, just in case somebody put an extra space at the end. This allows us to know where that final closing curly brace is. Okay? So, this guarantees that our string, this guy, does not have extra spaces at the end of it or at the beginning of it. So it'll cut those off, just in case whoever wrote this put some white space at the end. Okay? So what we need to do is we need to get rid of, just run this. We need to read up to, but not including this guy. Because we want to pass this part right here, to process room. That's the value for a room. Make sense? Okay. So, tell me, if we're looking at code that looks like this, where is the very first curly brace? It's at bucket 0, right? After we've trimmed. So, if I get rid of that, where's the next curly brace? The next opening curly brace? It's wherever index of tells me it is. Does that make sense? So the index of method will tell me where the first occurrence of an individual character or string is inside of a string. So if I can get rid of this guy, then what I can do is I can then use index of to find the next one. So let me show you that. So we're going to go ahead and we're going to say this dot JSON is equal to this dot JSON dot substring 1. That will get me everything from bucket 0 or from bucket 1 all the way to the end. Have we looked at substring in here before? No. Okay, so then we'll write our own since you weren't allowed to use that. Private string substring. So substring is going to take in a beginning, and it wants to cut down JSON from that point on. Okay? So, how would I write this? We should make this a quiz. It's a pretty easy question to answer. This would be a completely legit quiz. If begin is 0, I want everything from 1 on. So I'll create a little loop. For int I is equal to begin. I is less than this dot JSON dot length I plus plus. Answer is equal to answer concatenated with this dot JSON dot char at I. This dot JSON is equal to answer. Actually, why did I have it return a string? We'll have it return nothing and just update our global variable. Okay, so this takes in the beginning value. So we're going to pass it a 1 in this case because we want everything from bucket 1 on. It will build a brand new string. The loop is going to go through 1, or wherever begin was, all the way to the end of the string, building up a copy of JSON except for what was at bucket 0. And then we'll set JSON equal to that new answer. So this is our own version of substring. So to process cave, the very first thing we'll do is say this dot substring 1, and that will update JSON. It'll cut off that first opening and closing, well, the first opening curly brace. Now, what about the closing curly brace? Think about this. Think about our JSON as like cracking an egg. All right, so if we are removing the very first thing, Do we also want to remove the corresponding closing curly brace to get what's inside the egg? Does it kind of make sense? Okay. So why don't we have this guy take begin and end? So we have some flexibility with it. So instead of going JSON.length, we're going to say less than end. So when we get our substring, we're going to go from 1 to this dot JSON dot length minus 1. And then, so here, we'll just do that for right now. And just for a second, I'm going to make this public, just so we can call it from outside of here. So this is what process cave does so far. Process cave peels off the opening and closing curly brace that is wrapping the room that belongs inside of cave. That make sense? So when we run this, if we go out to driver, what's up? This is going to work, won't it?
It's not displaying it.
It will in a second.
Okay.
Well, right now it displays the entire thing. Then I'm going to say CSP dot, what do I call it, process cave? Process cave, which should remove the beginning and end thing, and then I'll go ahead and display it again. So this should be the before, this should be the after, showing us that we've removed, we've extracted the room portion of the cave from the opening and closing curly braces. So go ahead and run this. So here's our original. Our new one starts with the room and has that final curly brace removed. Make sense? Now, so we can continue making assumptions that things start at bucket 0. Inside of caveSOM parser, I'm going to set this equal to answer.trim. So we're always going to be working with a string that doesn't have white space in the beginning or end. Not the end of the world. You can always ignore white space. Just I think in this particular case, because of the way we're going about parsing this, or the way we happen to be going about parsing this without using a JSON parser, I think it's beneficial for us to assume that the very first character in the string is a real character and the very last is a real character, not a space. All right, so I'll run that again real quick and you'll see now there's no spaces here at the beginning and there's no spaces here at the end. Okay, so we've cracked the egg, dumped out the room that was inside the cave. Now, this guy's a room, correct? Now, the value of a room is what? This guy. So if we treat this as a variable, we have that is the variable name, room, let's say, and this is the value associated with that room. We want to get that value, correct? All right. So if I know I'm standing at the entrance of a room right now, what do? I call process room. So we're going to write a method, public void process room. Process room is going to pick up where, so I'm going to put a comment here. Ready, well here, we'll just actually do it. This dot process room. Process room now needs to go and get the value of the room from the next occurrence of the opening curly brace. Correct? So right now, if we look at our output, the value of room is everything to the end, starting from the opening curly brace. So I'm going to say this dot substring where's my beginning going to be? My beginning is going to be this dot JSON dot index of opening curly brace. So that'll tell me where the next curly brace is, the next opening curly brace. And the end is going to be this dot JSON dot length. Okay, so when I call process cave is going to crack the egg that holds the cave, then call process room. Process room should then whittle this .json down to just the value of that room. So now when we come out to driver, the second display should just give us the value of the room. The room part should be cut off. Okay, so now we just have the value of the room. Make sense? Now, a room knows how to process itself. What do? We need to find the first occurrence of treasure. Well, let's look at room here for a second. A room has treasure, whether or not it's true, followed by a comma. What was it funny? What was it? Impressive. Which part?
My high score.
Of what?
Don't tap the white tile. It's
not like the ghetto version of Flappy Birds.
It's number one on the this Play Store or whatever. So.
All right, so a room contains a comma delimited list. Here's our first value, treasure. Our second value is a room. This is the entire value of that room. Well, this is the entire value of that room. And our third value is another room. Right? All right. So we need to whittle that down even more. So the first thing I'm going to do is I'm going to get the treasure. So I'm looking for that occurrence right there. Correct? Now, tell me, what would happen if I used my tokenizer or I used split? We've dealt with both of those, correct? We've done tokenizer. We've done the string tokenizer, definitely. Have we used split before? Okay, unimportant. Tokenizer is good enough. They do the same thing, basically. So if I tokenized on the comma, what would I get here? In this particular case, it would actually in this particular case, we have bad code. There should be a comma here, separating that second guy. If you did it without the comma, it's not a big deal. Okay, so if we look at our code here, and I'm looking at just the value of our room, this guy right here, and I get that comma delimited. So let's first say we move past the opening curly brace and get ourselves that. The stuff that's inside of the egg that is the room. Okay? If I comma delimited that, what would I be left with? I'd be left with the first token being this, the second token being this, the third token being this. Correct? But we have an issue. That issue is what if inside of one of these rooms we had another room? Now all of a sudden our first token is this. Our second token is this. Our third token is this. And our fourth token is this. Probably not what we want, correct? We want to bust this guy apart. So we have part 1, part 2, part 3. How could we do that? Is there a convenient way we can do that given what the code looks like right now? Using a tokenizer? Do we see any patterns in here that we can recognize? Once I run into treasure, the next thing I'm going to run into is either a room or it's a closing curly brace. Correct? I think a few minutes ago I said that a room is a collection of a treasure, definitely has a treasure, correct? Every single room has a variable for treasure. It might be true, might be false, but it has a variable for treasure. And then it has 0 or more rooms. There's no guarantee that we have another room, correct? So, first thing we're going to look for inside process room. So this guy gets us our value, correct? Now, realistically speaking, if we're looking at our room like this, could we go ahead and just crack the egg right off the bat and get rid of the closing curly brace there and the opening curly brace here? Are they useless to us? Because we know we're already in a room, correct? So I can do that by just adding 1 here and subtracting 1 here. Now that will crack that egg. Now we're just left with the values inside of the room. Okay? So, next thing we're going to look for is we're going to look for treasure. So let's process the treasure, whether or not this guy has treasure. And what I'm going to do, just for some output in our program here, I'm going to do some out. I'm going to do system.out.println processing a cave. And then at the beginning of room, I'm going to print out processing a room, just so we can kind of see us walk through this. All right, so we are within a room right now. This line cracks the egg, correct? Gives us the values inside of the room. Now we want the treasure. Well, where will that treasure begin? If I run this real quick, the treasure begins right here. But the value comes after the first colon. That make sense? So is it true that all of this crap here is fluff? True statement? So I'm interested in where the next colon is. And I want a substring from that all the way to the end. So I can cut off everything before the true. Then I know I'm looking at the value for treasure. Well, how do I cut off everything before true? I say this dot substring, this dot JSON dot index of colon +1 to this dot JSON dot length, all the way to the end of the string. Okay, when I run this now, the very first value we have is my value for treasure. Okay? And the very last value is the value associated with our final room. Okay, so we're good here. Now, we need to get the value associated with treasure. How do I do that? How would you go about? If I have a string that looks like this, so don't overthink this. We're solving a hard problem using a bunch of baby steps. Keep whittling down our string. If I have a string that looks like this, how do I just get the value true? Professor Wall. He walks by, just looks in. 2 seconds later, he walks back. He's got a plan. Oh, that's brownie points there. All right, so how, do I need to make this a quiz?
Substrate prefers 5 or 6. And then
5 or 6. Why 5 or 6?
You just check if true is valid in there as well.
Okay, well, I want the value regardless of whether it's true or false.
Well, yeah, you need enough of the string to see if.
No, I don't. The value I want is everything up to but not including what? The comma. Correct? So I want to get everything up to but not including the comma. What are some ways I could do that? Well, I could use the tokenizer. That would be the nice, quick way of doing it, right? Substring method would be dangerous because I'm going to then cut down the string. And I wouldn't get the value. But that, I mean, we could have written the substring method differently to do what you're saying. Just because of the way we wrote it, the substring method is destructive to our global JSON variable. So don't send anything into the substring method unless you're willing to do some chopping. It's like a wood chipper. We should just rename it. We're going to. Highlight this. Right click. Can I refactor it? Rename. Wood chipper. Spell it right? Aha! You don't have to do that in yours, but I did it in mine.
Capitalize coin in Bitcoin. You don't capitalize chipper.
It's a good point. You happy?
Yeah, actually.
Good. So I'm happier too. It's good. Because when you really think about it, the chipper, that's the part that holds some weight, right? I don't even know what I was saying, but it might. I think it might be phrasing. I'm not sure. I honestly don't even know. Now I have to go to church tonight because of you people. Oh no, we got wings tonight. Are you coming with us, Abe? Yeah, you are. They have 60-cent boneless wings. It can't be better than. It can't be worse than your wife's cooking. So yes, good, perfect. Okay. Some people are helping me move out of an office, so for their manual labor, they're getting wings. What was I doing?
Bean chipper.
That's right. Oh, but anyways, if any of you are interested in helping do manual labor at 4 p.m., well, not everybody. You're welcome to come, and I'll buy you uh, buffalo wings afterwards. Because I figure the more people, the faster we'll get done, and then the quicker Abe can say, "I'm not going to come for buffalo wings," and get home to his wife. Did I get that about right? See, I actually am siding with Abe's wife here because, I mean, somebody's got to keep him in line. So, not as bad as me, but sort of. Okay, so we have our wood chipper. We just renamed that guy. Okay, so when we process a room and we're ready to process the treasure, we're gonna chip everything away up to we're gonna wood chip it. Get some sound effects here, and then we need to go ahead and get that first token. So I'm going to create a string tokenizer. In fact, actually, we might use this several times. So I'm going to create a global string tokenizer. Private string tokenizer. What should we name this guy? It's going to be a meaningful variable. Its job is to we always going to use it just to get the next value. We're going to call this guy the hatchet. All right. So we have to import java.util.string tokenizer. So down here in process room, we're going to say this dot hatchet is equal to a new string tokenizer, and we're going to pass it our JSON, and we're going to tokenize on the comma. Okay. Now we're going to do a little printing. We're going to say system.out.println processing treasure. We'll grab the next token, which should be our true or false. So we run this right now in our current version of the code. Is it a false? True. Our first treasures are true. So go ahead and run this, and there's processing treasure. We got our true. So now we can move past everything up to room, correct? All right. Actually, we can move past to everything up to this point. This is our next value for room. So this guy right now, well, actually it's on the screen. Oh, I'm already on the screen. Perfect. So I just read in this. The next thing I want to do is I want to process this room. Then I want to process this room. How do we process rooms? We call process room. That's how we process rooms. So I need to get this value right here. Now, isn't that what we sent from our caveson parser? We processed cave. We went from bucket 1 to the n minus 1. We just took the curly braces off. And then we sent that value to process room. So the value we actually sent into process room was a room in that format. So the entire value for that room. We want to do the same thing here. So we need to get everything for that room from the word room all the way up to the corresponding closing curly brace to this guy. That make sense? Where will that be? So I'm sitting right here. I'm going to get myself to the beginning of this room. I need to get everything up to, so it's easier to see in this code. I need to get everything up to this point. How do I do that? Well, what if I had multiple rooms in here? Just so we can see a pattern. So let's say this particular room that I need to process happens to have multiple rooms in it. How do I get this entire value? Right now my string looks like this. Everything I've highlighted there is what my current JSON string looks like. I want to get this part, then I want to get that part. How do I just get that part? Which is what process room expects. That's the type of string process room expects. Could I look for closing curly brace comma? Why won't that work? Because I have another one in the middle. What's wrong with the way we're going about doing this? We're treating it as a straight string parsing exercise, correct? But the problem is that JSON very much is implemented recursively. And we're partly doing this recursively by creating this process cave, process room type thing. But how would we walk through JSON? We want to capture the way JSON should be processed. What if I walk through this string one character at a time? So let's start at the very beginning. I'm going to walk through this literally one character at a time. I just hit an opening curly brace. What does an opening curly brace mean? It's the start of something. Yeah, it's a token, start of our next token. Now, we know the opening curly brace, if we're in process cave is always where we're going to start, right? Because this entire thing is a cave. We know that that opening curly brace is the beginning of the room. So what do? We move past that, and we call process room on this string. I'm walking along, I hit an opening double quote. What does that mean? What does an opening double quote tell us? Here, I'll point them out. Here's something with double quotes. Here's something else with double quotes. Here's something else with double quotes. Here's something else with double quotes. What does opening double quote tell us? A variable. It tells us that we're processing the name of a variable. Correct?
You have the double quotes around true.
Okay. It's true. So it's a variable or a value. Types of values in this are strings and what? Objects. Think of anything surrounded by opening and closing curly braces in JSON as an object. That's really the philosophy behind JSON. It's an object representation language. That's why it's popular amongst programmers. So if I walk through this one character at a time, I see an opening curly brace, start a new object. So I'm going to process a new object. First time through, I know that object I'm processing will be a room. So I'll call process room. Now, I hit a variable name. It's a room. So that's what tells me I'm going to be processing a room. Okay, this is the guy that says what I'm processing. So Cave reads in this. I read in an opening double quote, read it all the way to its corresponding double quote. I see that it's a room, so since it's room that I should be processing, I'm sitting right there with my string position. I'm going to call process room. Process room is going to keep going. We hit a colon. What does colon say? Not bare hands colon, but the rest of our colons. Colon says a value is coming next. Correct? If the next value starts off with a opening curly brace, keep in mind I'm currently inside of process room. When I read that in, I called process room. We hit the opening curly brace that says we are now processing a room. This is the value of the room. I hit another opening curly brace as I'm walking through this one character at a time. Well, I'm at variable name or a value. Build up to the closing curly brace or the closing double quote. I see that I have a treasure. Treasure tells me what? Well, that tells me it's the value I need to now process treasure. So I'll call process treasure. Process treasure then reads up to here, says, oh, what's coming next is the value. Reads to the next opening double quote, or potentially a curly brace, but in this case it's a double quote. So in our JSON language here, in CaveSon, we have two separate types of values. We have values that start with double quotes, we have values that start with curly braces. Values that start with double quotes are the values associated with treasure. Values that start with curly braces are the values associated with rooms. Okay? So we'll come in here, process through this. So we called, as soon as we read in this value, we said we're going to call something called process treasure. Why? Because we're processing a treasure. That guy will come in here, get everything from the treasure, print out, we found treasure is true, get to the comma. Now we know what's coming after a comma is another variable. Notice we do not have a comma for our last variable. So if we hit a comma, we know that the next thing that's coming is a variable. So we can process that variable. Variables, again, come in two flavors. Treasures and rooms. Okay? So we process the variable. What kind of variable it is? Well, we read in the variable name, this guy's a room. What do? We call process room. Process room reads in the value of the room. Goes through. We hit an opening double quote. Read that in. It's a treasure. What do we do when we see a treasure? We call process treasure. We get the value for the process treasure. Now we hit a comma. What do we do when we hit a comma? We call process variable. Process variable comes in here. It sees that we're looking at a room. Well, what do we do when we see a room? We call process room. We process the room. It starts walking through. We hit a variable. Read in the variable. It's treasure. What do we do when we see a variable named treasure? We call process treasure. That gets the value of our treasure. What does it mean when we hit a closing curly brace? Object is finished. An object is being finished. So as far as our recursion goes, after we process the treasure, when that guy's done, we're going to bounce back to the call where we were processing this room. And as soon as we hit that closing curly brace, that room knows that it's done being processed. So it will end. So when we see that, we're now sitting right here. This call to process room has now finished. So now we're back in this call to process room. The one where we read in the treasure, then found a room, processed that room. Now we're sitting back here. We have a comma. What does that mean? That means we're expecting another value. What kind of value? Well, we call process variable. Process variable reads in room. What do we do when we see room? We call process room. Process room finds this. We found a variable. What do we do? Process variable. This guy says treasure. What do we do when we see a treasure? We call process treasure. We get its value. Now we're back to our room. We hit the closing curly brace. What does that mean? That means the process room that we called associated with that guy has now ended. We're done processing that room. We're back to the call where we were processing this room. This is the recursive calls. What happens? Well, we hit a closing curly brace. That means that this call to process room has now ended. Then we hit a comma. What does a comma mean? It means we have another variable. What do? Process variable. Process variable says, I found a room. What do we do when we find a room? Call process room. Now we're in our room. Now we found the beginning of a variable. We read in that variable. Well, what do? We call process variable. We read in that variable. Variable's treasure. So we call process treasure. That gets the value of treasure. Then what happens? Well, process treasure ends. We're back in process room. We hit the closing curly brace. Closing curly brace says, we're done processing this room. So this call to process room now ends. So we're back in this call to process room. Then we hit the closing curly brace, which means this call to process room has ended. Does that make sense? That's our original call to process room. And where are we when we fall out of that original call to process room? We're in process cave. Process cave hits the closing curly brace, and we say we're done. Make sense? So we walk through this one character at a time, and we just transfer logic throughout our program. We just write a couple of methods. And through recursion, this guy should work itself. Okay? So, back into CaveSon parser. Our constructor's still legit. It reads all the stuff in. Do we even need a wood chipper anymore? We're never whittling down our string. We're just walking through it one character at a time. So it's sad to see it go. Okay, but no more wood chipper. Okay, now for right now, I'm going to empty out process room, process cave. I'm going to go ahead and write in our public void process variable. And I'll also write a public void process treasure. These are all the guys, the players that we just spoke about. Okay, so let's grow this through our code. So the very first thing we're going to do is we're going to call process cave on this entire dealio. Okay? And we're going to start walking until we finally hit the opening curly brace. Okay? But remember, we're going through our code one character at a time. So that means we need to keep track. I'm going to go ahead and get rid of our tokenizer for right now. Private int curpos. and we'll set this dot cur pos equal to 0. That's the first position we are in our string, in our JSON string. Okay? So we're sitting right here at bucket 0. What does process cave do? Walk until we hit the opening curly brace. That's what we do. So while this dot JSON dot char at cur pos is not equal to an opening curly brace. We happen to know it'll be an opening curly brace the very first time because we did a trim. But for logic's sake, we'll say this. As long as we're not looking at an opening curly brace, what will we do? We're going to say this dot cur pos plus plus. Keep walking until we finally get to that opening curly brace. Then what do? Well, as soon as we're looking at the opening curly brace, we now need to call process room. But process room, right now we're sitting right there. That's cur pos. In order to now process our room, well, I don't think we should assume it's process room yet. So what we'll do is we hit the opening curly brace. The next thing we're going to look for is an opening double quote, which is the beginning of our variable, so we can call process variable. Even though we know that the first variable will be a room, let's just handle it generically. Okay? So we walk to the opening curly brace. We're there. Now find the beginning of the first variable. So while this dot JSON dot char at cur pos is not equal to a double quote, this dot cur pos plus plus. Now, are we seeing a pattern here between these two? Aren't these basically the same loop? Just one of them's looking for an opening curly brace, the other one's looking for an opening double quote? Probably this has a method written all over it. So we're going to come up here. We're going to write a little method. Private void move to char C. I'll steal our little while loop here. And instead of doing a curly brace there, we're going to say, well, it's not equal to C. Move forward. Okay? So now when we walk to the opening curly brace, we'll say this dot move to char opening curly brace. So we'll walk to the opening curly brace. Now, find the first variable. This dot move to char double quote. Now we're sitting at the beginning of the first variable. So what do? We call this dot process variable. Right? That's how we process variables. So I'm inside process variable now. My job, I know if I'm in process variable, I'm at the very beginning. Cur pos points to the very beginning of a variable. I need to build up the variable up to the point where I hit the next double quote. Maybe that's called get variable. So I'll write another little method. These are all going to be private eventually, but I just wrote them all public for some reason. I think I changed one and then just got into the habit. So private void get variable. Actually, he's going to return a string, not a void, sorry. Private string, get variable. This guy is going to start off with a string answer. It's the empty string. And we're going to walk from where we are right now until we hit a closing curly brace. So we'll actually start this guy off at the I want to keep the, we'll do this. So we'll go ahead and say cur pos plus plus. We'll move past that opening curly brace. Or opening parenthesis, or opening double quote. I'll get it eventually. Opening double quote. So we were sitting right here. So what I did is I just incremented by 1. So I'm sitting at the very first character in my variable name. I want to walk and build up everything until I finally hit my closing. That make sense? We're going to do that. Sort. So we're going to say while this dot JSON dot char@curpos is not equal to double quote. Answer plus equals this dot JSON dot char@curpos and then curpos plus plus. So this will get our R, then our O, then our O, then our M. Is it true that M is not equal to the double quote? That's true. So we'll get our M, increment curpos. Is it true that double quote is not equal to double quote? That's not true. So we will not go into the body of the loop again. So right here, answer is equal to my variable name. Correct? I'm going to go ahead and say curpos plus plus. Just move right past that end double quote. All right? And then I'm going to return answer. So that's how I get a variable. What did that guy just give me? He gave me that and left curpos right here. Make sense? All right. So now I can call say string var name is equal to this dot get variable. And now I have a variable name. That variable name will either be room or it will be treasure. If var name dot equals room, and understand this is the string room, not the string containing the string room, so it's not that. We cut those off. So I'm just seeing, is it equal to room? If that's true, what do? I call this dot process room. Else if var name dot equals treasure, I call this dot process treasure. That's what process variable does. It reads in the variable. If it's a room variable, process it. If it's a treasure variable, process that. Make sense? Okay, well, let's say in this particular case, it was a room. So I'm going to call process room. Remember, I'm sitting right there currently. What I need to do is I need to move to the opening curly brace. Correct? Move to the opening curly brace. Pretty much just like I did here. And then I'm also going to move to the next variable. And I'm going to do what? process that variable. Process room. Walk to the opening curly brace of room. Walk to the beginning of the first variable in room. Keeping in mind that there's no rule that says you can't have inside of a room, treasure, room for your variables. JSON supports things being in any order inside of an object. So this will handle that. So walk until we hit the opening curly brace. That's the beginning of our room object. We might already be there, but walk until we get there. Walk until we hit the beginning of our first variable, then process that variable. Okay, well, what does process variable say? Process variable says, get the variable. If it's a room, call process room. A recursive call. If it's a treasure, call process treasure. Process treasure, in this case, that's what we're looking at. We're looking at treasure. What does process treasure do? Well, it'll move to the opening, double quote. Now we want to get that value. So we'll get true. That make sense? So inside of process treasure, we want to move to the double quote. How do we do that? Actually, find the beginning of the variable value. Now I want to get that variable. I can actually use get variable there, right? This guy does the exact same thing. He'll get me that value and leave me right after it. And I know we're out of time. So I'll call get variable. That'll get me that value. And then I'll print out system.out.println process treasure value. Okay. Put a little comment in there reminding me to start here. So we'll come back. You can kind of see where we're going with this. JSON is a recursively defined language, and we're walking through it recursively. And by solving a difficult problem using a bunch of easy steps, you'll see your life becomes easier. All right, we'll come back to this on Tuesday.